Good evening, sir. This is Sarim Abbas Rizvi, and my roll number is 2025. So, I am going to talk about wall shear stress and skin friction coefficients. So, let's move forward. So, overview, I am going to talk about what is wall shear stress, how is wall shear stress calculated, and what is skin friction coefficient, how is skin friction coefficient determined, application of these two, and conclusion. So, what is wall shear stress? By the definition, wall shear stress is the force per unit area of a body surface that is tangential to the flow direction of a fluid. So, these thing we call it as a wall shear stress. Formula The formula for wall shear stress is tau equal to mu du by dy, where tau is the shear stress, mu is the dynamic viscosity of the fluid, and du dy is the gradient of velocity in the direction perpendicular to the surface. Here is the diagram. Significance: wall shear stress is critical for understanding and predicting boundary layer behavior, which affects the drag and lift forces on a body in motion through a fluid. So the unit is wall shear stress is typically measured in unit of pascals or dynes per square centimeter. How is wall shear stress calculated? So it is calculated by three terms. There are multiple methods of this. So first one is boundary layer visualization. To calculate, one method of calculating wall shear stress involves visualizing the boundary layer on a surface using techniques like oil flow visualization. Second one is boundary layer theory. Another method involves using theoretical models like boundary layer equations of Prandtl and von Karman, which describe the behavior of fluid flow near a surface. And the last method is computational fluid dynamics. This is the modern method, involves simulating fluid flow using computer models based on Navier-Stokes equation and other mathematical models. What is skin friction coefficient? By the definition, the skin friction coefficient is a dimensionless quantity that represents the ratio of skin friction drag to dynamic pressure. Relationship to wall shear stress: the skin friction coefficient is directly proportional to the wall shear stress on a body surface. So that means it is directly proportional to the wall shear stress and varies with factors like Reynolds number and surface roughness. Application of skin friction coefficient: the skin friction coefficient is an important parameter for designing aircraft wings, marine vessels, and other vehicles that move through fluids, car, and etc. There are many vehicles. How is skin friction coefficient determined? So as we see in the wall shear stress, how it is calculated. Skin friction have also three methods: wind tunnel testing, boundary layer theory, and numerical stimulation. In numerical stimulation, we use computational fluid dynamics like we used in wall shear stress. Boundary layer theory is also same. Wind tunnel testing: skin friction coefficient can be determined experimentally by testing scale models of bodies in wind tunnels and measuring drag forces. We have seen these two already. Application of wall shear stress and skin friction coefficient. So we have used this in multiple industries like aeronautics, biomedical engineering. So first one is aeronautics. Wall shear stress and skin friction coefficient are critical for designing efficient and safe aircraft that can fly at high speeds and altitude. Wing design with smooth surface and laminar flow, turbulent flow control to reduce drag, heat transfer consideration for hypersonic flight. In biomedical engineering, wall shear stress and skin friction coefficient are relevant for understanding and treating biological systems that involves fluid flows, blood flow and vascular diseases, artificial heart and blood pumps, microfluidic devices for drug testing and analysis. These are for aeronautics and biomedical engineering applications. Another two, so here we can see the pictures where we use the applications. So as we can see the aircraft, and this is for more biomedical engineering. marine engineering, where this is the third application. Wall shear stress and skin friction coefficient are important for designing ships and underwater vehicles that can achieve high speeds and maneuverability. So ships and underwater vehicles like submarine, etc. Surface roughness management for reduced drag, cavitation prevention for propellers and turbines, turbulent boundary layer control for maneuverability. So this is the conclusion. Wall shear stress and skin friction coefficient are fundamental parameters of fluid mechanics that have important implication for engineering and science. As we continue to explore the intricacies of fluid flows, we can expect to refine our understanding of wall shear stress and skin friction coefficient and apply these concepts to new challenges and innovation. So this one is for the future, further what we will understand. So this is it for my presentation. Thank you.